Okay, Gautam, you're live.
Thank you very much, TJ. Are we at 1 o'clock?
We are.
Perfect. Hello, everybody. Let's go ahead and get started. Thank you all for joining us today for our presentation on how to design the perfect flyer. Thank you so much to Edwards Air Force Base and the AV Air Show for hosting this. My name is Gautam Nagaraj. I'm a thermal engineer over here at Northrop Grumman, and I'm so excited to teach you guys today about paper airplanes and how to build them. My job currently is a thermal engineer, and a lot of people ask what that means. And basically, all I do is basically the Goldilocks system. We make sure things don't get too hot and too cold. But you guys don't need to worry about any of that today because we're going to be talking about paper airplanes and how they fly. So let's go ahead and get right on in. How today is going to work, I'm going to give you guys a little introduction, tell you a little bit about myself, because you guys all want to know that clearly. But more realistically, what we're going to do is we're going to talk about the basic forces on an airplane. We're going to go ahead and actually build our plane together with a guided building session. We're going to go ahead and test our plane, and then we're going to do a little debrief, and then we're going to figure out how to redesign it. We're going to talk about some advanced building concepts. We're going to do a second build, which in that opportunity, you guys are either going to get a guided session with me about how to build a more complicated plane, or you guys will be able to go ahead on your own and build whatever other paper airplane you'd like. And then we're going to go ahead with the second round of flight testing. So as I mentioned, we're going to be building a couple planes today. So please make sure you grab some paper before we get started here. I know I've got my sheets ready to go. Hope you guys too. All you need is traditional 8.5 by 11 sheets for the paper airplanes that we're going to be building today. I'll give everybody a couple seconds here to go get their paper if they don't have it already. Traditional printer paper works fine as well. That's what we're looking for. Okay, hopefully you guys have enough time to go grab some paper. A little about me, as I said, I'm a thermal engineer currently working on space projects. Before that though, I went and got my undergraduate degree at the University of Pennsylvania, where I studied mechanical engineering, applied mechanics, and earth science and geology. And then I went over to the University of Michigan, where I got a degree in aerospace engineering. I've been at Northrop Grumman since 2015, so it's been almost 5 years now, which is pretty incredible. But outside of that, I have a lot of interests. I love playing soccer. I love coaching soccer, watching soccer, basically anything soccer. It's me. I love baking. Chocolate chip cookie cake is definitely my favorite thing to bake and what everybody kind of wants. And in general, just a huge sports fan. I even started co-hosting a podcast called Sports Masala. So really excited about sports. But outside of that, human space exploration is definitely a big space interest. But all that's enough about me. Let's talk about why you're actually here, and that's to learn about planes. So let's talk about the basic forces on an airplane. As you can see at the bottom, there are 4 forces on a plane. Well, 4 directions the forces apply. Can anybody tell me which directions those are? Think about it for a couple seconds. And I know we have a big Zoom call here, so it's going to be a little different about how this works. But if you thought about it, we have 4 forces on the airplane, and they operate in those 4 directions. Makes sense? But what are each of these forces? So we actually have a couple poll questions now that we're going to do with you guys to talk about each of these forces. So TJ, who's our lovely moderator for today, is going to go ahead and launch the first poll. What do you call the force in the plane that makes the plane go up? You guys get about 20 seconds now. Go ahead and respond to the poll. Okay, TJ, why don't we close the poll? I think people have responded. Let's see what the results say. Hey, woo! Great job. It looks like 77% of people said lift, and that is the correct answer. We had a couple people say weight and delta. Okay, those aren't the correct answers, but we'll talk about weight soon, so don't worry. And no one guessed Fred. Good job, guys. Lift is the correct answer. That is the force that makes the plane go up. Counteracting lift is the force that makes the plane go down. TJ, would you like to launch the second poll, please? What do you call the force that makes the plane go down? Guys, get another 15 seconds here to go ahead and respond. Okay, I think everybody's go ahead and responded by now. So let's check out the results. Woo! 70% said weight, and that is the correct answer. Great job, guys. We had a couple people say delta, one person say lift, and I think probably one person said Fred as well. No, Fred is not the right answer, and you'll see through this presentation, Fred is never the right answer. So just a heads up, guys. But no, we just talked about lift as the force that makes the plane go up. Weight is the force that counteracts that makes the plane go down. So now let's talk about the force that makes the plane go forward with poll number 3. What do you call the force that makes the plane go forward? Your options today are strong, thrust, weak, and drag. Okay, TJ, I think we're good. Results say 86% say thrust. Woo, good job, guys. That is absolutely correct. It is the thrust that makes the plane go forward. We had some people say strong. No, the strong force doesn't really apply here, and drag, which doesn't make the plane go forward in this case. But moving on, let's start that again. We'll launch poll number 4 and ask the question of what do you call the force that slows the plane from going forward? Again, your options are strong, thrust, weak, and drag. Okay, I think we're good, TJ. Hey, great job. It looks about like 80% of y'all said drag is the correct answer, and that is, woo! Nope, we're not talking about weak force here or strong force or thrust in this case. Thrust makes the plane go forward, not back. So great job, guys. You were able to go through all 4 forces. And this is nice, right? We're talking about planes and forces, but we need to understand them a little bit better if we're going to build the best paper airplane. So let's go through each one of them in a little bit more detail. Well, let's start with lift. Lift, as we know, is the most important force for airplanes, right? It's not flying. Is it really an airplane? We know lift, it's counteracted by weight, and how much lift you're going to get is defined by this fancy equation that you see on the screen here. If you see the equation, you're super scared by it, don't worry. We're not going into a lot of detail about this, but it's really helpful when you can see an equation and kind of break it down into its component parts to see how it affects what we do. So you start with CL, and that's coefficient of lift, and that's some complex value that relates to your airfoil shape. Don't worry about that today as we build paper airplanes. The second term in that equation is V. You see a V squared. V is how fast you throw it. It's your velocity. So the faster you throw your plane, the more lift you can get. Keep that in mind when you're throwing your paper airplane today. The next term you'll see is rho. That's like that fancy squirrely looking P. That's rho is the density of air. You can't change this. You're all pretty much going to be throwing at the same altitude. So don't worry about it. That's how air is. Can't change it. And then lastly, you have A, which is the area of your wings. This is something you can change with your paper airplanes. The bigger your wings are, the more lift you can get. And if you get a lot of lift, your plane will do that. The opposite to lift is weight. And weight is the nightmare for every engineer. It makes the plane come down, and it's caused by gravity from the Earth. The equation for weight is super simple. It's just mass times gravity. So when we talk about weight, it's about how heavy your plane actually is. The lighter your plane is, the less lift you'll need to keep it flying. You can't change gravity. The only thing you can really change in our circumstance is mass. So it depends on if you use a whole sheet of paper or a half sheet of paper or a quarter sheet, or maybe you decide to use cardstock or origami paper. These are different ways you can change your mass of your plane and therefore the weight as well. So if you're a really, really heavy plane, it's gonna go womp womp. Let's not let that happen. Next, we have the thrust force. This is essential to go anywhere. If you want to move forward, you need thrust. It's counteracted by drag, as we mentioned earlier, but thrust is pretty complicated when you actually go into the equations and understand how it's being imparted by the engines and the combustion systems that we use to lift planes off the ground. But luckily for you guys, we're not talking about real planes today. We're talking about paper airplanes. So all you need to understand is the more thrust you use, the more drag there is, so be careful. And how hard you throw your plane is how much thrust you're going to get. So if you throw your plane really hard, you've imparted a large amount of thrust on it. If you let it go, you've implied a lot less thrust on it. So just be careful in which direction you're imparting that thrust, because that's the direction it's going to go in. If you throw it straight into the ground, well, guess where it's going to go? Straight into the ground. If you throw it up into the air, it's going to go that way for a foreseeable period of time. So if you give it a lot of thrust, you go right off the screen. Lastly, let's talk about drag. And drag force is interesting because it slows you down. If you're standing still, it's not really affecting you. But drag is caused by air, right? And we all live and breathe in air. And the drag force is actually represented by this fancy equation on the screen. And like we did for lift, I want to kind of break it down real quick, where we have all these terms that are on the screen. We have CD, and that's a coefficient of drag. That's some complex value that relates to your cross section. All that means for you guys, though, is that the wider the front of your plane, the more drag you have. So if you get a nice pinpoint top, that'll help with reducing the amount of drag. The next term is V, again, V squared in this case, and that's how fast you throw it. As we mentioned with lift, the faster you throw your plane, the more drag you're going to get. Rho, again, same, is density of air, can't change that. And lastly, A is the area of your wings. The bigger they are, the more drag you're going to get. So I want to stop here for a quick second and just notice the similarities between lift and drag. We mentioned a couple minutes ago that, hey, if you throw your plane really fast and with big wings, you're going to get a lot of lift. Well, the flip side to that is, yeah, you will, but you'll also get a lot of drag. So it's something to consider and optimize when you're building a plane, because realistically, you don't really want your plane to do this. Womp. But enough about theory, right? We wanted to give a quick 5 minutes into plane theory, but now it's time to build, guys. That's what you're here for. You want something interesting and fun. So how today's going to work is we're going to have 2 build sessions. The first is going to be a guided build session. We're going to build a pretty easy plane called the Dart. See it right here. And the second build session will either be you guys going off individually and building some plane that you've already built before, or we're going to be actually building together a much more complicated plane. So that's how today's going to work. When we build our planes, I want you guys to consider the forces we talked about. You know, lift, weight, thrust, drag. See how that impacts how big you're going to make your wings. How much paper do you want to use? How sharp do you want to make your nose? These are all things to consider when we're building paper airplanes. And what's always fun with paper airplanes is to compete against your friends or your family members. And how me and my friends always compete is that we want to get the longest straight line distance. So if your plane goes squiggly, 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 does some really cool things, but just goes a foot away from you, that's not the best. Whereas if you throw a plane and it goes really far in a straight line, that's how we like to say as a winner. But all you guys are welcome to do your own little challenges and competitions to see who can make the best paper airplane. Before we start building, we have a couple polls here that I want to make sure we're all on the same page before we get started. So TJ, can we load poll number 5 and 6? Thank you very much. So we're going to answer these polls together. They're 2 questions, should be fairly easy. The first question is, bigger planes will make the airplane do what? Fly for longer, go into space, dance crazy, or nosedive? The second question is, a pointy nose will make the airplane do what? Sneeze, fly in loops, fly faster, or be heavier? So guys, go ahead and take like 30 seconds. I know there's 2 questions here to respond to them, and then we'll go ahead and check out the results. Okay, TJ, why don't we go ahead and close the poll? I think everybody's responded. Let's see the results. Wow, there we go. 77% said fly for longer with question number 1. That is correct. Yes, very good job. I think someone said dance crazy. Not sure planes do that, but maybe. Bigger wings will make the airplane nosedive. 14% of people said that. It's a possibility, guys, but that's due to different factors. So that's not really what the answer is to that question. And go into space, if anybody can make the plane go into space from just throwing it, that's really incredible. You should talk to the Guinness Book of World Records for that one. Second question we have is a pointy nose will make the airplane. And 83% of you guys got it right. Fly faster. That is correct. Good job, guys. Let's go ahead and end this right now and go ahead for our first building session. Build session number 1. Congratulations, guys. You made it. So what you're going to need today is one 8.5 by 11 piece of paper to go ahead and build the first plane. The plane we're building now is going to be called the Dart. It's a fairly simple plane. So you guys all have your paper. I'm going to go ahead and build it with you guys and their instructions on the screen as well for how to build it. So we're going to start by folding it hot dog style, just like this. Make sure you line up the edges so you get a good fold. Okay, give it a nice crease too if you'd like. So now that you have your paper, why don't you go ahead and open it back up. Now that we're here, we're going to go ahead and fold the corners in. So we're going to take the corner and we're going to fold it into the center, just like this. You can use the center line that you just made as a good guideline for where your corner should go. Make the fold, be sure to give it a nice crease. And this is where you should be after one side is folded. Now we're going to go ahead and fold the left corner the same way. Boom. And here we go. We now have the step of the plane done. So the next step is we're going to do is we're going to fold this edge down to the middle of the plane, like so. So you want this side to look like this. So all we've done is we started out here and we folded it in like this. I know this is pretty easy for some of y'all. I'm just going slow, make sure everybody's keeping up with this. We're going to do the same thing now for this side. Now you should have your plane looking just about this. Sort of looking like a plane already. It's a little triangle. So now what we're going to do is we're going to go ahead and we're going to fold it in half. Using the center line we had from before. Here we go. Your plane should look like this now. Again, we have a nice little triangle here, but it's not really a plane, right? There's a little nose here, but where are the wings? Well, that's what we're going to go ahead and build right now. And this is a place where you can kind of get a little fancy or different. Depends on where you want to fold to make your wings. So what I'm going to do is I'm just going to fold this line to meet the bottom. So I'll show you like this. So I folded my section down to meet it like this. We were here to start just like this, and then I folded it down to meet the bottom line like that. I'm going to go ahead and do this now for the other side as well. So I'm going to go to this side of my plane and fold it back down. Get a nice fold just like that. So now my plane looks like this. We're not done yet though, because we need to puff up the wings. So what we're going to do is we're going to take it and you're just going to pull your wings flat like this. And there you go. You have now built a dart. So this plane, why don't you guys go ahead and give it a nice throw. Woo! Just like that. So I'm going to give you guys now a couple minutes to go ahead and do some flight testing for your plane. Throw it around, throw it in different directions, throw it up, throw it down, throw it with a lot of force, barely give it a push, and try some different things. A lot of things we talked about. But for those of you who were following along and kind of messed up, or your paper ripped, or you lost yourself, or you got late getting paper, don't worry. The information is still on the screen, and you guys have a couple minutes now to go ahead and try to build this plane. First, I think the hardest step in building this plane is when we go back to one of the initial steps that we have. And basically after the step in the top right-hand corner, when we're here, the real question is, how do you fold it down into this? That's the hardest part. So as long as you get that, I think the rest of the plane is fairly easy, guys. So go ahead and make sure you do that. Make sure you do it pretty symmetrically on both sides. That's the key for this plane. Symmetry is very helpful. And then you can finally get to a plane that looks like this. I think people had some time now to do some flight testing. And those of you who are struggling to build, hopefully were able to build it in time. If not, all these videos are going to be saved and recorded online, so feel free to reference it later. But now, part of the engineering process is not just the design part and then building it and testing it. Now we need to understand what went well, what didn't go well, and make some changes and iterate across the process. So that's what we're going to do here today as well, right? We're all engineers. We want to do a great job. So using the Q&A feature on the bottom of your screen through Zoom, those of you who are on Zoom, why don't you go ahead and respond to the first question on the screen, which is, what went well? You guys built this plane, you flew this plane, what went well? Did it fly quickly? Did it go in a straight line? Did it do everything you wanted to do? Was it easy to build? Go ahead and throw some stuff up there. And I'm going to go ahead and check out the answers as you're posting them. Ooh, it went fast. Yes, great. Glad to see that. It made a turn. Oh, interesting. That may be one, because you wanted it to, but two, maybe your wings were a little offset and it kind of started turning in one direction. Something to be careful of when you're building paper airplanes, for sure. Everything went straight, smooth. Glad to hear it. Fast, easy to build, flying really well. Wow, this is great to hear. Even when you barely pushed it, it glided for a little bit and then went down. Awesome. Okay, great. So hearing a lot of really positive responses for what went well. So that's great. No weight, no drag. Wow. Okay, definitely a little lighter there. Glad to hear it. Okay, so now we're going to go ahead and answer the second question on the screen using the same Q&A feature. Is what didn't really go as planned? What surprised? And we'll lump it in with question number 3 as well. What surprised you? So we've talked about a lot of these things went great, but what didn't go exactly as planned? What were you like, I didn't think that was going to happen. So go ahead and use the Q&A feature to go ahead and respond to that question as well. You crashed a couple of times. Ooh, that is tough. I've crashed my fair share of paper airplanes too, so don't feel bad. Luckily, you know how to build it now, so you can go ahead and build another one. Not anything. Nothing went badly. That's great, right? That means you built the perfect plane. You don't need me anymore. It fell to the ground on the first try. Oh boy, you accidentally hit your mom. This is something we're going to talk about later. But guys, don't throw your plane at anybody else, and especially not your mom. Oh. Ah, when it nosedived, it bent my plane when it hit the ground. Yes, well, that's what happens to paper, hard surfaces. It's just going to change what looks in the front. So got to be a little careful, guys. Okay, so a lot of good responses. Some small things here and there which surprised you guys. Definitely the crash landings are not good for the structural integrity of your plane. So good things to keep in mind going forward. So let's go ahead and we're going to stop the Q&A for right now. And I think since all you guys said it went so well, you guys are ready now for some advanced building concepts. And these are 3 things I wanted to highlight for you guys today because it's really important when building paper airplanes. And the first is material selection. I know we talked about drag and trying to get bigger wings for lift and throwing it harder to get more thrust, but we didn't really talk too much about how to get rid of weight. I mentioned earlier with different materials, and that's really the way to do with paper airplanes is use lighter materials. That way you can reduce the overall weight. Now, the opposite side to that is you have to understand the environment you're flying in. A lot of you guys are in classrooms or back at home doing this in your studies, your bedrooms, and you don't really have much wind in your environment, right? It's pretty benign for the most part. But if you go outside and you throw your paper airplane, it's going to be a little different. There's going to be wind, can make your plane move around all sorts of crazy ways, and the lighter your plane is, the more easily it's going to be pushed around by the wind. So that's definitely something to consider. The second thing you want to look at is workmanship. No matter how great of a design you have, it's not going to work unless you build it well. And that's so true in engineering, as we see, right? You can have the perfect design, but if you don't build it well, it's not going to work. So it's important you choose materials that are easy to work with. Paper is pretty easy, right? But if you try to use cardstock or something like that, or you want to use some fancier material, that might be harder to work with. Just keep that in mind and make sure you still do a good job folding. And one last thing I want to talk about is center of gravity. So if you hold and it really depends on how you're throwing your plane. If you hold your plane too far forward, it's just going to go straight to the ground, right? If I hold my plane here and try to throw it, whoops, that's all that's going to happen. If I take my plane and hold it here and throw it, it's just going to stall out and fall back to the ground. We don't want either of that. So we want to make sure we hold it at a nice middle point right here. Get a good center of gravity. That way we're not pushing it down or just pushing it straight up. So TJ, why don't we go and throw ahead and throw up our 7th poll here. And this directly addresses one of the questions we had in comments we had earlier about where you should throw your airplane. So question is, you should throw your airplane into the wind, safely away from other people, by holding it not too close to the nose or tail, or all of the above. Go ahead, guys, take 20 seconds to answer this question. Okay, I think people have answered. Oh, wow. Okay, let's talk about the results here. This is interesting. We had 2 answers get 41% of results. So let's talk about this. We have a lot of people said safely away from other people. Great job. Yes, it's important to do that. But the correct answer in this case is the other answer that everybody picked, all of the above. Yes, you need to do all 3 things when you're throwing your paper airplane. If you're throwing it outside, into the wind is typically a good way to go. Definitely, as a lot of people noted, you should throw it safely away from other people. And as we just mentioned about center of gravity, yeah, you want to hold it not too close to the nose of the tail. So in this case, those of you guys who guessed all of the above, you're correct. Great job. So with that in mind, you guys have built a plane, talked about a plane, and now you're like, okay, we got some advanced building in. So let's go ahead and build another one, right? We got time. It's only halfway through the session. And that's exactly what we're going to do. So this is build session 2. I'm going to go ahead and lead us through a guided building session for one of my favorite paper airplanes. And that's the belly button glider. If you guys don't want to do that, or you think it's going to be too hard, you're welcome to go ahead and build some other plane you've built before. You're welcome to go ahead and build the dart again as well. Maybe you might want to play with it, change how much paper you use, maybe make the wings a little bigger, smaller, see how that works. So feel free to do that as well. But I'm going to go ahead and lead our session now on how to build the belly button glider. And all you're going to need is the same thing as what we started with last time, and that's one 8.5 by 11 sheet of paper. So I actually have a pre-step here before step 1, and that's we're going to go ahead and start the same way we started the dart. And that's where we're just going to fold the paper hot dog style, just so we get a nice center line for when we're building. So go ahead and fold the paper like this. Make sure you meet your edges correctly and you get a good center line. You're going to find that it's going to be pretty useful as we build this plane airplane. Okay, we have our plane paper and we can unfold it. You want to start here. What we're going to do is the same thing we started with last time, is we're going to take the corners and we're going to fold them to the center just like that. So same thing as we did with the dart, we're going to take our corner, we're going to fold it into the center. So just like this, you're going to want to do it for this, you're going to want to do it for this side as well. You get some nice good creases on the edges right there. Your plane should look like this after step 1. Hopefully I'll give everybody a minute to get here. And now we're going to do with step 2 is we're going to go ahead and fold this corner down. This top section down. So just like it's done in step 2, we're going to go ahead and do this. This should make your plane look like a nice envelope. We have some questions about how this is going to be shared and stored. Yes, it's going to be saved, the presentation. I think TJ and Air Force and the Air Show will definitely be able to give you guys some more information. I think there's a live stream on YouTube going on right now as well. But we're right here, and we're going to go ahead and move to step 3, where we're going to fold the corners in again. So we're going to take our corner, and we're going to fold it in. Look like this. I'm going to do the same thing for this side as well. Okay, so now we folded it. It looks like this. You probably thought the first couple steps of this paper airplane are kind of repetitive, right? We fold in the corners, we fold it down, we folded the corners again. Well, don't worry, we're not going to fold it down again. So I'm going to give people a couple seconds to get to this point where we are right here. And the next steps are a little complicated, / they can get a little tricky. So I want all you guys to follow along pretty closely, and I'll try to repeat them a couple times. So what step 4 is we're actually going to go ahead and we're going to want to fold this edge to meet this edge. So kind of like this. So we started out here, right? Everybody's with me here. And then we're just going to fold it up such that these two edges meet. So I'm going to go ahead and do this on the other side of the plane as well. As I said, symmetry is important, so we're going to go ahead and do it on this side as well. If at any point you guys are really struggling, feel free to throw something in the Q&A feature. If I can, I'll try to stop or slow down or see if I can answer any questions as we're going along here. But essentially at this point, your plane should look like this. Okay, now what we're going to do is we're going to take that flap that we just made and we're going to actually fold it back down. So what you're going to do is you're going to fold it and you're going to come back down like this. This is what it should look like. You guys have built your flap like this, and you go ahead and you fold it down like that. Yep, so our flap is like this, and we just took half of it, and we folded it in half like that. So we're gonna go ahead and do the same thing for the other side as well. We take this and we fold half of it back down. So we want to make sure that we have the flap and we fold it nicely in half, just like that. Okay. The next step is a little trippy, so just bear with me here, is we're actually gonna sort of unfold, but not really. What we're doing is we have our flap here that we folded back, and we're gonna flip it down like that. So we are right here, and we're gonna go ahead and leave your fold and fold it like that. And we're gonna do this for both sides. So we have our flap here, and we're just gonna flip it down like that. Okay. Hopefully everybody's with me. And this is a step which is going to tell you why, or how this plane gets its name. That's the belly button glider. And that's because we're going to make the little belly button fold. So we're going to take the little triangle down here, and we're just going to fold it right on up. So just like that. So our triangle was here. We went and folded it like that. Give you guys a couple seconds to catch up if you're just following along. As we're going along, make sure you get some nice creases in your folds. That often helps. I'll check the Q&A as well to see sort of if there are any questions. Okay. So now that we're here, we're going to actually go ahead and we need to start building the wings, right? So we're going to go ahead and fold this back in half. So on the side where you've put your belly button up like this, you're going to fold it back just like that, such that your plane looks like this. Okay. Now the last step in this is that we need wings, right? We started saying, oh, we need wings even at the end of our dart, and that's what we're going to do. And again, at this point, you have the choice of how big you want to make your wings. You can fold it all the way down the front, and that'll give you much bigger wings. You can fold it at the top to give you smaller wings. But what I'm going to do is I'm going to take this surface, and I'm going to go ahead and mate it to this surface at the bottom. So I'm going to take this, and I'm going to fold it down. It's a little bit tougher fold, right? There's a lot more paper involved, so just be careful. Might be a little more difficult. Don't worry, give it a shot. So as you can see, this was my fold right here. From here we started, and I folded this side down to meet the base, and that's how I got my wing. I'm going to go ahead and do that now for my other side as well. So same thing. I'm going to take this corner, or this side really, and move it to the base of the plane. Crease. See a lot of paper, really hard, but here we go. We've now folded it like this. The last step in building this plane is just to open the wing. So we're gonna go, and there you have it, folks. You guys have just built a belly button glider. So why don't you take it now and give it a nice throw. Woo! Even better than the dart. So I realize this plan is a little more challenging, so I'm going to give you guys a couple more minutes. If you guys messed up in the middle, you wanted to start from the beginning, to go ahead and do that. And those of you who were able to successfully complete it, why don't you go ahead and give it some flight tests, just like the dart, see how it performs. Throw it up, throw it down, throw it with a lot of force, less force, but be mindful of how you throw it and to avoid find vases or something that's around you, or don't throw it at your mom either. Just be careful. As you guys are doing the flight tests, feel free to throw in the Q&A, how it's going, if things are going well, if things aren't going well. Okay, I think people have a lot of chance now to go ahead and try building their planes and testing them out. So let's go ahead and move forward here. And we're almost out of time, right? We did a flight test 2. Some of you guys have started posting your debrief comments, what went well, what didn't. And that's an important part of the engineering process. So since we want to wrap up today, and I want to kind of go over what we learned, right? We talked about the 4 forces on an airplane, and I hope you all remember what they are, because if you didn't take away anything from this presentation, I hope that's the one thing you took away. So TJ, would you mind launching our last poll, please? And that is, the 4 forces that act on an airplane are thrust, drag, weight, air, weight, lift, drag, Fred, lift, weight, thrust, drag, strong, weak, gravity, and Fred. In any case, go ahead, guys, take 20 seconds now to respond to this poll. Okay, TJ, I think everybody's responded. Survey says 76%, lift, weight, thrust, and drag. Woo! I was hoping that was going to be 100, but 76% is quite good. Congratulations to everybody who got that right. Whoever guessed the first one, no, air exists, but it's not the name of the force. And then for the second option, come on, guys, we talked about Fred. We acknowledged Fred was never going to be the right answer. So you guys just must be messing with me. God, you guys all know lift, weight, thrust, and drag are the 4 forces. Things to consider as well is consider the environment. So when you go challenge some of your friends on the playground or something, be careful, there's a lot of wind outside, so be careful how you're throwing it. And really remember this engineering process of design, build, test, redesign, rebuild, retest. Trust the process. That's what us engineers do on a day-to-day basis. And that's a really great way to develop your planes and develop any product, really. So hopefully you guys take that away with you from today's lesson. And a great job to all of you guys for participating today. I know people say everybody's a winner, but you guys are truly aviators. You're building planes, you're learning, you're going to keep building more. So hope you guys had a great time today, and you guys can fly away just like that. As we wrap up, I'd love to see what you guys have built. So go ahead and post some pictures on social media if you can. Hashtag Northrop Grumman, hashtag defining possible. We'd love to see what you guys have been doing. Also, if